Of course, you want to make sure that everything is working well. So either that there was no issue during the transportation.
Or we group these KPIs, or we give additional informations to different user groups. The one is operation and safety. That there is a problem. The module went back to the factory. They replaced some.
And last but not least, in our just small analysis of just projects from the last 6 months.
Hello, everyone, and welcome to Sinovoltaics webinar. My name is Rasa Yakaitis. I'm Media Manager at Sinovoltaics, and I will be moderating today's webinar on battery energy storage systems. A stable grid depends on storage assets that deliver consistent performance under real-world conditions, and that's why we need battery energy storage systems of the highest quality. So how can we ensure the maximum health of battery energy storage systems? Let's find out the answer together in today's webinar. Before I introduce our speakers, a few quick notes. This webinar will last for about an hour. 2 expert presentations will be followed by a Q&A session. On the right-hand side of your screen, you can see the Q&A chat. Please use the Q&A chat to submit your questions at any time during the presentations, and I will address them to the respective speaker at the end of the presentations. Please do not use chat for your business promotion purposes, as these messages will be deleted. The chat is only for questions. Thank you for your understanding. This webinar is being recorded and will be uploaded on Sinovoltaics YouTube channel. If you don't want to miss the newest content updates on YouTube, don't forget to subscribe our channel. So now let me introduce the 2 stars of today's webinar. So first, we have Lutz Morawiec today, Head of Algorithm Development at Volytica Diagnostics. Lutz is an electrical engineer with over 20 years of experience in battery testing, R&D, and algorithm development. And now at Volytica Diagnostics, he leads the algorithm development team. Lutz has dedicated his entire career to understanding the most critical component of the energy transition, that is the battery. And today, Lutz will present how Volytica Diagnostics help companies use the batteries to their full potential. And yes, that's a vision statement of Volytica's that I borrowed. And Lutz will also present on how they detect defects that standard FATs cannot detect. And just a note and congratulations, Volytica Diagnostics has been recently recognized as one of the most innovative battery software companies. So Lutz, very excited to have you with us today. The next expert in our webinar is my dear colleague Arthur Claire, Director of Technology at Sinovoltaics. Arthur is based in Lausanne, Switzerland, and he supports IPPs and EPCs in deploying reliable solar modules and BESS through advanced traceability and quality inspection services. With his deep technical expertise and strong industry insight, he has been instrumental in driving innovation at Sinovoltaics. And today, Arthur will talk us through the best quality control procedures that we see today. We'll highlight the most frequent defects that we found during the factory acceptance tests, and we'll also share eye-opening data on how undetected issues can lead to significant financial losses. Before I hand over to Arthur, I would like to briefly introduce Sinovoltaics. So Sinovoltaics is a Dutch-German company providing technical compliance and quality assurance for battery energy storage systems and PV worldwide. We offer inspections, factory audits, ESG reporting, and traceability audits for utility-scale developers and investors. And with over 15 years of experience, we have audited more than 350 PV and BESS factories globally, covering all major components you would typically find in these projects, inverters, transformers, cables, etc. And final thing before I hand over the virtual microphone to Arthur, as an attendee of this webinar, you have a unique opportunity to join Arthur on an exclusive tour to China, where you'll visit some of the world's leading BESS manufacturers, Portis Edge, Great Power, Sunwoda, Goshen, Lithium, to name a few. This will be a small, diverse group of just over 20 participants, giving you the chance to see firsthand how the BESS manufacturing process is managed. And one of the biggest highlights of the tour will be the quality debrief sessions hosted by Arthur himself after each factory visit. And these sessions will be straightforward and insightful. No sugarcoating is coming from Arthur, just clear evidence-based feedback on the quality procedures manufacturers often overlook. The program includes a 5-day guided tour with 4 hotel nights, all meals, internal bus travel, and 1 domestic flight covered. We have a special discount code available for our Sinovoltaics audience. So if you'd like to receive the discount code, please drop me a message at the email address that I'm just going to share now. And if you want to know more about the Solar Plaza Battery Tour China, you can see the information in the link that I just shared. So now, finally, Arthur, I bring you on the stage. You can start your presentation.
Thank you, Raza. And good evening, good morning, good afternoon, everyone. And yeah, as Raza mentioned, if you want to be stuck with me for a week, you should join this factory tour of battery manufacturers in China. But now let's start with this webinar about hidden defects and real cost of quality defects that we can find at energy storage factories. So to start this small presentation, I want to ask you one question. What do you think is the most frequent issue that we find during battery energy storage system, factory acceptance testing, or FAT? Is it issue with the thermal management of the batteries, issue with the water leakage within the container, issue with the fire suppression system, or with the coating fitness of the container? Or if you have any other idea, please maybe share it. So you have the poll option in the chat or in front of your screen. I'll give you 30 seconds to look at it. Okay, so we have a lot of feedback. Looks like that the thermal management of the batteries is the lead answer, but actually it's not the main issue that we find. It's one of the most. So all of those issues are, I think, the top 4 most frequent issues that we find during BSS FAT. But the most frequent one is issue related with the fire suppression system. So if you are worried about thermal issues within your BSS, you should be extra worried about the fire suppression issues. And to give you some stats, we find issues with fire suppression system, or in other words, that the fire suppression system is not working, in 25% of the project that we inspect. So in 25% of the projects, of the energy storage project that we inspect, we find at least one container with a fire suppression system that is not working, which is extremely worrying, as you can imagine. But thank you all for your participation. I see a strong engagement from the audience. Thank you. All right, so let's start with some, I would say, basics, but still extremely relevant today. And let's start with BSS quality control today. So first of all, factory audits. So for example, if you want to qualify one new supplier for your battery cells, battery pack, or energy storage system, we strongly recommend that you run a factory audit there, either about quality or even ESG or supply chain mapping. It's extremely relevant to be able to compare, I would say, apple to apple in terms of the maturity of the factories. Second, I would say factory acceptance test, as we have just seen. It's an extremely critical check to make sure that your BSS is leaving the factory in the right state without any defect. And this is actually the last step at which the manufacturer can still easily correct and replace potential defective components. So you should really emphasize a strong quality control during that manufacturing step. Then we have the site acceptance testing. So now the BSS arrived on site. Of course, you want to make sure that everything is working well. So either that there was no issue during the transportation of the energy storage systems, and also you want to ensure that the integration on site, both with the grid and also potentially with the co-located asset, whether it is wind or PV, or potentially some off-site, some off-grid assets as well. So it's extremely important to have it signed, and we always recommend our clients to have someone from the manufacturer to be there with you to train your team on site, and also if there is any issue, you can kind of hold them hostage before they go back home. Last but not least, we also recommend strongly to all our clients to use battery monitoring solution, like the one from volytica. So by monitoring your assets, you'll be able to detect if there is any early deviation of any KPI, whether it is related to capacity, voltage, and also temperature, and it's one of your main concerns. And so it will also, what is really, really critical is that you will have ownership of the data. And in case there is any need for a claim to be triggered with your BSS integrator, you will have enough evidence to prove that you need the BSS assets to be replaced. Then let's focus on FAT. As I mentioned, it's, I believe, one of the most critical steps in terms of quality control. So it's composed of several steps. First part about visual inspection. You want to make sure that the container looks nice in terms of color, of course, company logo, and also that there is no dust, no issue in terms of rust, for example. This is where, for example, we will check for the coating fitness. It was one of the answers. It's also one of the most frequent issues that we find as part of our FATs. But also we will analyze inside of the container, so making sure that the cabling of all the battery packs is done per specifications, I would say, and everything is matching, is looking as they're supposed to, so no scratch, no issue, no damage, or no loose screws. Also, we'll make sure to have some electrical testing, whether it is related to insulation or, for example, earthing. Also, we will check for the voltage of some battery module and battery racks. So it's quite standard, making sure that everything is working, seems to work correctly. After that, we'll have a full performance testing. So making sure that the entire system is working correctly at full charge or full discharge. So for a full cycle, both charging and discharging. And you want to make sure here that everything is working correctly, because it's kind of the first time that the energy storage system is working together. And last but not least, as we have seen, this is where we find our most frequent defect, but the safety testing. So you want to make sure that the heat sensor, that the temperature, that the heat sensor, smoke sensor, and the chemical sensor all are working well. And so as we have seen, it's where we find the most frequent issues. So you want to make sure that everything is working well. And so, but unfortunately today, there is really no regulation or really no standard on what should be done in terms of FAT. UL standards only mention that insulation tests should be done systematically, but apart from that, not much. So it's kind of up to you to make sure that in your procurement contract about your BSS equipment, that those topics are being covered. So we, of course, provide services to advise our clients about it. And after the webinar, we're going to share one document for you. But so here are kind of the most common issues that we see about shortcuts taken by the suppliers. First one, that unfortunately some players just don't perform factory acceptance testing on all or some of their energy storage system, which is a huge warning and a huge red flag to me. Unlike battery packs or battery cells, the manufacturing process of energy storage system is still highly manual. So it's not because we have inspected 99 BESS that went well that the next one will go well. Unfortunately, we see a lot of those issues. But first of all, if a fire suppression system is not working, it's not, of course, done on purpose. It's usually done because of wrong behavior by one operator, and it's something that you can only see if you check each container during the FAT. Second, and it's unfortunately a trend we see often, is to save time and to save costs on the FAT. Many even renowned suppliers are not doing performance testing or only on sampling. And this is, I believe, a really huge issue. This is a massive issue today that we see. And that's why also we have developed the BESSential service that we have mentioned, that we're going to mention during this webinar. But yeah, performance testing, as I mentioned, is kind of the best way to make sure that your BSS is working well. And so you want to test that at the factory, because if you test this either on site or even later during the operation of your energy storage assets, well, good luck to find the replacement parts or to have the right claim management. It's just going to be a huge mess for you, a huge waste of time and waste of money. And unfortunately, some our clients that used to be, I would say, lose on performance testing before, they had to pay huge penalties, for example, to their grid operator, because they could have spotted issues as part of the performance testing that was not performed, unfortunately. Next, we see a lot of sampling FAT. As I mentioned, energy storage system, the manufacturing of energy storage system is still a huge manual process. So performing sampling FAT is really, I would say, could be acceptable for huge projects where you have hundreds of containers, but for small projects, for me, it's a no-brainer to do 100% FAT of all your containers, especially if it's the first time that you are using those solutions. I'll give you just one example for this. We had a client that bought like 60 containers, so like a 140 megawatt hour case. And we were only able to do a FAT on one container. So I'll let you imagine like what's the chance that we will find anything, and what is the chance that many issues passed through and in the end ended up at the client site, and now it's kind of struggling with potential defects that may be triggered because of lack of factory testing. And I would say last but not least, about shortcuts, I'll mention about limited testing. So this is part of performance testing. You want to make sure that this is tested at maximum power at the manufacturer premises. Because here also is kind of an excuse that many suppliers found, is that since they can only test at limited power, like 0.1 P, for example. So of course it will take too much time to do the FAT, because doing a full charging cycle will take more than 10 hours. So you want to make sure, and you want to mention in your contract that the performance testing is being run at full charge and full discharge capacity. That's it for my first part of the presentation. I will now leave the floor to Lutz. Lutz, I think you can come back on stage, and I will leave it to you.
Thank you, Arthur, very much. I was actually just trying to get on the stage, but it took me a while. So hello also from my side to this webinar, and what I'm going to talk about is more or less this part of the performance test especially. But before we dive into it, I would like to introduce briefly our company, so that you know, probably Sinovoltaics is a bit better known than volytica diagnostics. So this company has one vision, and I think Rasha already shared it. Like we think that every battery must be used to its true potential. What does it mean? Or why do we have this vision? Electrical or like lithium-ion batteries or electrical storages in general are, from the environmental impact and so on, very expensive. Like they are containing a lot of, let's say, critical raw material. They also have impact. So they, like all the advantages we get for the energy transition, they are not for free. So I think we must use this expensive, as well money-wise expensive, and as well also resource-wise expensive device, yeah, as much as possible or as long as possible. But this already starts, in our opinion, with the FAT, like directly when the battery is leaving the factory actually. So it's like our company, we have like more than 10 years of practical experience with batteries. So we first, like there was a first European e-buses monitored in Dresden actually. So we are based in Dresden. And out of that, first at the Fraunhofer Institute, we launched a battery monitoring platform, the first one. And then in 2019, we started to, let's say, professionalize it or spin it out to have like a scalable solution, which we are now offering to a great group of already clients. You see our clients and partners, you see them here on the lower right side. And right now we are monitoring above 3 gigawatt-hours of batteries actually. And how do we do that? Well, every battery, as you might know, every stationary system, they have something which is called battery management system. And this electronic devices inside the battery are already recording the relevant data which we need. And so we need no additional hardware. We are using the existing data, and we are plugging this to our system and to our cloud-based environment, which we call volytica or VDX engine. And to connect your system to this platform and to also parameterize the algorithms, we are focusing on having as low as possible onboarding effort, no extensive lab tests, and so on. And out of this monitoring, we are creating KPIs for you, which we cluster in 4 groups. Like the baseline group is what we call BESSential. Actually, this is already more or less everything which you can calculate, starting from usage statistics up to SOH and different base alerts and so on. And then on top of that, we group to, we group these KPIs, or we give additional informations to different user groups. The one is operation and safety. This is more or less about alerting and trends and where you can have safety issues. And the next one is about investigate and resolve, which is also then helping you to resolve these issues and to investigate deeper into it. And last but not least, it's lifetime monitoring and value retention, value management of the system. So summing this up, we only use standard data for our monitoring platform. We have an auto configuration engine, so no extensive lab tests are needed. And this is very important, we directly integrate in often existing SCADA integrations. So everything is API based on our side. And of course, we have an innovative feature scope. One of our features I would like to introduce a bit better or a bit deeper. We call it the VDX Sentry. Like the Sentry is the guy watching your battery, like the virtual 24/7 battery expert, we call him. As you might imagine, like such a monitoring platform creates a lot of information, creates already KPIs and numbers, time series data. We are creating, we call it here a flood of alerts. There are a lot of alerts which have different reasons, threshold alerts. Some are just data glitches which your BMS is creating or something like that. And the Sentry, this is very important, can also go back in the asset history even for years to cross-check the plausibility of events and so on. And we also can do a cross-asset check, like did we see that in similar sibling assets or not? And out of that, we create valuable information for the client with a focus on being actionable. Like we don't say you just have a violation of whatever, We also explain you what this violation causes and what measures can be could be taken to avoid that or to get rid of it. This is our, let's say, normal pipeline. What does it has to do with the FAT? This question is very relevant. Like some years ago, Arthur and our CEO Claudius were sitting together, and we realized that similar approaches could also highly help to bring the factory acceptance test to a next level, which means that we are kind of applying this VDX engine now to what happens during the factory acceptance test. And why do we do it? Why do we think it's reasonable to do this testing, especially also this performance testing, before you go live with your battery or with your BESS system? One thing Arthur already mentioned is we are proposing 100% testing depth. So every container, every module inside the container should undergo this performance test or this BESSential test. Why? Because most of the problems which we've seen so far are not a systematic problem. A BESS system is, like manufacturing a BESS system is up to now at least partially a manual process. And sorry for saying that, humans make mistakes. So if there is one mistake in one container, like there is no statistical evidence how much you find. So please try to test everything. But on the other, this sounds now very expensive. But actually, as Arthur said, there is no real additional effort which is needed for this test. Sounds strange, but the reason for that is this performance tests, or at least some electrical tests, are anyway done by the manufacturer, but they are normally not providing the data for an independent assessment. So the data is actually there. And the next advantage is, as early you find a problem, then as cheaper it is to fix it. Like if you find something at the factory acceptance test, you can fix it right on site. If you find it already at the site acceptance test, then it's way more expensive. Then you have to call the OEM, spare parts have to be sent out and so on. And even worse, if you find it later on in the usage, you have downtime, so less revenue, and the costs are even more increasing. The test is very quick, so we assure you that at latest, normally we are way faster. You get the test results within 24 hours after we got the data. And also, like now you might be a bit afraid when you heard our cloud product that we are needing a cloud integration via API or something fancy. No, we designed the product to keep it simple, and you can share whatever data format with us, CSV file, JSON files, Excel files, bus traces, simply via whatever, email, SharePoint, FTP. So you just need to receive the file and send it to us, and we will do the job. What is the result of what I call our job now? You get a comprehensive assessment of your battery system before you start operating it. Of course, and this I think is the most relevant and most valuable part. After the assessment, you get an expert summary or an expert assessment of the things. Not only that we say like, hey, you crossed some thresholds or some things are not fulfilled or here's something strange. We also explain you why we think it's strange, why this can cause problems, and what you should do or what you should ask your manufacturer about to do. But of course, you don't get only this overall summary, you also get a list of each and every check with a very, in the end, simplified red, yellow, green traffic light system, where we say like green, everything is fine, yellow, ask back to the manufacturer, red, this is a clear violation of whatever a warranted value or something like that. The KPIs which we are checking, and this is just a summary of it, is not only but we do it, of course, the standard KPIs like round trip efficiency or available capacity, what you can directly map to your maybe data sheet of the asset. It's also about and resistance indication, of course. We are checking voltage protection anomalies. We are checking the thermal behavior of the system, very important. Like under this performance test, the battery has to perform some load cycles, so we also can have a look at the thermal behavior. And we look, very important, also at what we call here system balance, or cell and subsystem homogeneity or inhomogeneity. As you might know, a battery, even a container, like consists of 1,000 cells, which kind of pretend to be one big battery at the same time. But internally, hundreds or thousands individual cells are working together, and they have simply to be balanced and aligned with each other. Otherwise, the battery system cannot work. I will have an example later on for that. We check for other abnormal conditions in electronics, in thermal anomalies, and so on, SOC quality, and a very powerful tool, in my opinion, is this peer group comparison. Some also of the later shown examples, there is no threshold violation. There is also not an intrinsically wrong behavior of the battery. But like if one out of 100 of, we call it siblings, like the same parts in this battery, a rack, a module, is behaving differently, then it's already a bit strange. Like they are all produced and should be very similar. So this is also a very powerful tool. I already talked a bit about like, how does it look like? I said it's no time, actually it doesn't cost relevant amount of time. This is kind of the plan we lay out to have the results as early as possible. So we start, of course, everyone has to live from something. We start with that you order this FAT on our side, or at Sinovoltaics side, to be precise. And then already we start working on it. So we ask you to provide us a data sample from your OEM that we can already check if every relevant data which we need is available, and we can also derive the specifications and everything out of that. And after this first, let's say round, we give you a piece of paper where we agree on the data which we use and the test specifications. So it's already transparent from the very get-go what we will test and what we will receive. Then there comes a phase where we have to work internally. We write what we call a data adapter, that we can also automatically analyze your data, that everything runs smoothly. When you send us the file, we can immediately run our algorithms on that. And then after some really agreements, like we have to know when this FAT happens to be as fast as possible, we get the results, we do an automated analysis. You get the first version of the reports, which are like immediately sent out. And after some final checks by our experts, you get a final summary with, which I showed you with also executive summary with some deep findings, and also putting this into actionable items for you. And now I talked a lot how in theory this looks like, and you might now ask, what results did you find, or which value did you create for your clients? And I brought 3 examples with me. The first example is a standard capacity test, like a test which everyone should do with every container, or with every part you are actually investigating. And we have this example here from a kind of a large battery storage system, 50 megawatt-hour system, 23 containers. And what you can see here in this diagram is, like in orange you see the threshold. So actually every container is above the threshold. So you might ask, now what is the finding? Everything is fine. True, everything is fine. But there was a way higher, first of all, capacity and round trip efficiency than nominally specified, which is actually good. It's you can be happy if every container is bigger than what is specified by the manufacturer. But in this case, for us, like we realized that the spread between the containers was up to 10%, like between the smallest and the biggest one. And this has operationally no direct impact, we can say, but still it raises questions how the manufacturing is done. Like if you assume every container is the same because you ordered 23 of same containers, then it raises at least questions about an inconsistency in the production. So already here you have kind of this quality check against your OEM. Is he doing good, or is he providing what he proposes to provide? Second example, also taken from a real BESS, from a real factory acceptance test, of course now zoomed into this test quite much. What you see in this diagram is the voltage of the highest and the lowest cell within a container. I already said it, like each battery container consists of hundreds or thousands of cells, and each of them behave a little bit different. And what you see here is like the full capacity testing cycle. So discharging, charging, and discharging. And you see that there is a deviation between the blue and the orange line, which means that the highest and the lowest cell of a brand new, just the factory leaving asset, are already deviated remarkably in this case, or noticeably, as I wrote it here. You see these dotted lines or the dashed lines. None of the cells breached a voltage violation. So if you would just look at probably the report from your manufacturer, they would say everything is safe with the system, and they are not lying. Everything is safe with the system because no voltage limit is breached. But first of all, like if batteries are disbalanced, or cells inside a battery are disbalanced, this means actually that some of the capacity is trapped. Because like if the orange cell is empty, the blue cell cannot be discharged anymore. So the orange cell is limiting the capacity to the lower end, and vice versa does the blue cell to the upper end. So you don't have enough, or you could use, if the battery would be balanced more, you could use more of the available energy inside. And as I said, it's not critical or outside specification, but it's not expected in a brand new system. And as we don't know the reason for this disbalance, this can get a severe issue over time. Like if this disbalance increases, one cell might be stressed more than the other one. This is then a problem that this cell dies earlier and even can lead to severe failures. Or the voltage spread increases and voltage limits are breached. So this was also one thing where we went back to the manufacturer and asked if he can confirm, or if he can, that he should explain the reason why this battery here is so disbalanced. Last but not least, I already said it, we do this very powerful tool is this peer group comparison. So we are going back to this 23 container BESS system, 50 megawatt hours. And what you here see is an assessment of the temperature inhomogeneity of the system, which says like how big is the temperature spread inside a container between the highest and the lowest temperature in the system. And this is now for the math freaks of you, this is now made relative to the power flowing through the system, but this is just a side note. So what we realized here is that one module, the orange one, showed a noticeably higher temperature inhomogeneity than its peers. So it was more than 25% above the average. Like everyone else showed a normal temperature behavior, this one was standing out. And this is temperature spread inside a container is an indication for a problem with the thermal management or even a damaged cell. And after this check, we went back to this can lead also as the voltage spread to significant performance problems or even a safety issue. If like temperature spread is uncontrollably high, this can lead to severe problems in your system. And like what you can also see in this graph with this mark with this asterisk and the dash line, like the OEM, the manufacturer accepted that there is a problem. The module went back to the factory. They replaced some modules inside this container, and the thermal issue was done, or was gone, not done. So you see here that this really has an impact on, or can have an impact. And most of the, or all of these findings which we presented here would not have been found without this test, which could lead to severe problems in the future, or will increase your costs while running the system. Now, with this slide, I'm at the end, looking already forward to the discussion after the presentation, but now I hand back to Arthur, who will continue the presentation.
Thank you, Lutz. And yeah, as you can see in the chat, my colleague Raza has shared the link to the white paper that we have written with Lutz. So do not hesitate to have a look at it after the webinar, because before that, I want to share with you kind of some data from 2025 about this BESSential service that Lutz mentioned. So we have applied, just for information, on BESSential on around 9 projects of over 350 MWh. We have only applied this to so-called tier 1 Bloomberg BESS manufacturers, and we found issues in 2/3 of the projects. So here it's stark reminder that while I think the Bloomberg tier 1 rankings for both PV and for BSS are quite interesting, they really don't mean that you should trust them blindly, and that if you are not careful about the kind of controls, the kind of quality control that is being performed, you may have really unpleasant surprises. So let's look at those defects. To give you some stats, so we found actually many of you were right. As part of BESSential, so as part of a really comprehensive analysis of the data generated during the performance test, we found that thermal issues are the vast, I would say 2/3 of the issues that we found. So it could be either an issue with one cell or with one pack, or also we have seen cases where each of the containers were above the threshold in terms of thermal issues. And what is really interesting here is because the traditional FAT focus only on checking the capacity of the container as well as the round trip efficiency, RTE. They really oversee, they really don't even look at the thermal implications of the performance test. That's why running BESSential is, I believe, absolutely critical if you want to ensure that your BSS assets will perform as expected for 10 or 15 years. So yeah, I mentioned thermal issues are the most frequent ones. We also found issues related to voltage and also current issues, meaning that when we reach the end of the charge or the end of the discharge, we have some cells or some pads going below the voltage or the current threshold. We found it in some cases. And also we have kind of other cases, that's what I put in the last 20%, that I call system setup issue, is when we had issues with kind of other parts of the analysis of the different parameters. So it could be related to SOC calibration, for example, or others. But yeah, if you had to remember, and many of you were right about it at the start of the webinar, the thermal issues are really critical to watch for. As I mentioned, Raza has shared a white paper we have written last year with Lutz, and as part of it, we try to do some financial implication of not running BESSential, because it's the issue when you invest into quality. It's quite hard to understand, okay, how much am I going to save on my energy storage project. So we try to do some analysis of a thermal issue happening as part of the white paper that will translate into accelerated losses in terms of accelerated degradation of some of the containers. And after, we may have some alarms being triggered after 5 years in this case, that may generate some unscheduled downtime that will have a huge impact on the P&L of the project. And after that, since you had some issues, you want to launch a claim management process. But as I mentioned previously, this is highly time consuming. You need to provide a lot of evidence, and it's also a lot of cash consuming. So we also included that into our analysis. And so from our white paper, we found out that the cost, the financial impacts of not finding the issue we have found as part of the white paper could have resulted in more than 600,000 USD of losses, so which is obviously huge. And so here I tried to do something similar for some 3 projects that had thermal issues last year. So it's kind of some information to give to you. I put the project sizes. So as you can see, projects were different. And also what is interesting to see is that the potential impact of the thermal issues are different, because in some cases I mentioned that the issues were related to some packs. In others, it was related to several containers. And in some cases, it might be related to the vast majority of the containers. So of course, the financial impact will be different in I would say any case. But what you want to find, what you want to understand is that as soon as we find an issue, it will have been a no-brainer to perform BESSential. And I think it's really what I think you should keep in mind as part of it. So here, if you just look at how much we potentially saved our clients with for those 3 projects, it's around $1.3 million of potential losses that we prevented thanks to the BESSential analysis. So yeah, as a conclusion for this webinar, I wanted to mention that I mentioned earlier that a huge trend that we see in the industry now is that the BESS integrators, they really try to reduce the FAT running time, and so they really try to reduce the testing time of the performance test and the sampling of the containers that are going through the FAT. Yeah, we are going to share one specific document after the webinar with you, but it's really important to include those quality clauses and making sure that you have access to the raw data so that we can run BESSential as part of the inspection, which is currently, to be fully transparent, the main challenge that we face. As you have seen in the previous slide, as soon as you start to go beyond the traditional FAT of just checking RTE and the capacity of the container, you really start to see some issue, especially related to thermal inhomogeneity. And last but not least, in our just small analysis of just projects from the last 6 months, we found that potential losses could have resulted over $1 million of money. So it's of course something that no one wants to experience. And in any case, it's not. We have not covered, of course, cases where for example some fire got triggered, but it's not something we want to use as a baseline for our financial analysis. And I think that completes our presentation with Lutz. I think now we can move to the questions.
Thank you, Arthur, and thank you, Lutz, both of you. Arthur, thank you for sharing the root causes of most common failures detected thanks to BESSential in 2025, and also practical insights into how to make sure your BESS procurement contract works in your favor. So we'll share the document in a follow-up email that was whispered to me by Lutz's team. Lutz, thank you for cracking the code for us on how volytica tool works in real life and what data it analyzes. I see that in the question chat box we have many questions, so let's jump straight to them. Okay, so I see a question from Mikkel. With the FAT, you are still dependent on the manufacturer's measurements. How is it ensured that those are reliable? Because bad manufacturers might also have bad measurements. Perhaps this is a question for you, Lutz.
This is a very good question, and the short answer is, at the end, of course, we cannot assure that. We have to live with the data which we receive. This might sound very sad, but in the end, like let's say the data cannot be, like if they would really manipulate data, let's say, and do the things, okay, we on volytica side would be, in the end, to be honest, very powerless. I'm just being honest here. But like normal sensor issues, also we try to avoid as much as possible to even use faulty data, or for example, one thing is like if you have an offset in the current sensor, which would lead to a wrong capacity assessment, we would at least realize that and could re-ask for that. I don't know if this answers the question. I saw also kind of, sorry, Rasa, I don't want to make your job, but I saw a follow-up question. Wouldn't it be better if an independent party would measure the things? From my perspective, purely technically speaking, I would say yes. But also, I don't know what you say. I would say it's rather impossible to ask manufacturers to do something like that or to accept something like that, right?
Yeah. So just to add on your answer, I think the risk of getting fake data is also reduced because Sinovoltaics team is also there as part of the, I would say, standard FAT. So we are there to make sure that the standard capacity test as well as the standard performance test is done by the book. So of course, after, if we have one container with a battery capacity of 5.1 megawatt hour as part of the traditional FAT, at 5.5 as part of the BESSential analysis, it will be easy to spot. So that's, I think, a really important way to ensure that the data is legit, and it's also, I would say, more complicated to face the data than you think, I believe.
So one thing I would like to add on is to clarify this a bit more. Our tests only rely on time series data. Like we take voltages, temperatures, and current into account, and also the BMS SoC, which can give valuable insights. We are not relying on an already measured capacity by the OEM or something like that.
Okay, thank you, Lutz, for clarifying that, and thank you, Arthur, also for your input. Another question we have from Bert. Do manufacturers perform cell-based monitoring? Some, none, or all? I wonder, as it only takes one cell to have excessive dendrite growth or thermal runaway and cause a fire, and the rest then is history. So perhaps a question for you, Lutz.
Again, a very interesting and very good question. I mean, in the end, as I said, we are relying also on data from the battery management system. A battery management system have to record each cell voltage. So in theory, we could also do our assessment on cell level, but the amount of data would increase dramatically. A workaround, or to not use cell data, but still be have an opinion, let's say, on if there is a faulty cell. We are relying on having the highest and lowest voltage into the system, which I also showed as an example. So if there is a faulty cell inside, let's say, a module or a rack, it will show up even at the end of discharging or at the end of charging, and we will detect it. So in the end, I would say we don't need cell level data, but what you said at the end, it's right. It's just one cell which leads to a problem, not the whole battery. Or it can be just one cell which leads to a problem, not the whole battery. So it's important to look at cell level, but for this you don't need cell level data.
Okay, thank you. Also, again, a question for you, Lutz. You mentioned in your presentation that a customer needs to obtain a file from its OEM, for instance, but what file does it need to be? How to get that file? From aging test machine, charging discharge data, you mean? Could you answer that one?
It's actually, as Arthur said, and maybe Arthur, you can add on after my answer. These performance tests are often done, at least partially done, at the factory. So they are charging and discharging the battery, the container, the rack, on whatever level you do the test. And what we need is a trace of this measurement.
Okay, Arthur, do you want to add on this one?
No, yeah, it's true that we use the data generated as part of the performance test of your container. So it's after our team gather this raw data, and we'll then process this. We will then process it as part of the BESSential service.
Okay, thank you. A question from Simon. What trends are you seeing among your clients? Are more and more of them requesting BESSential? Perhaps, Arthur, you can answer that one?
Yeah. Well, it's kind of funny because we have more and more companies contacting us because they had issues in their first energy storage project. So now that they experience some quality issues, they are interested to understand how they could improve their way of operating. And so, of course, they are super interested by this BESSential because they understand that because they had quality defects, they understood that as soon as you have an issue, it's a huge mess to have some replacement parts and to have it covered by your warranties. So that's why you fully understand the part of BESSential, and that's why we are quite successful, I believe, into helping our clients to add the right contractual clauses to make sure that we can do our job as part of the FAT and as part of BESSential. And that's why also we will share this document after the webinar, because it's also the main challenge that we face as part of BESSential, that sometimes there is no mention of any data access. So the manufacturers will just mention that since there is nothing mentioned in the contract, they have no reason to share the raw data as part of the FAT, which is to me insane, because you are paying millions of euros or millions of dollars for your BSS, and you don't even have the right to check what's going on at the FAT.
Okay, thank you, Arthur. Interesting question from Risky. How do you manage the transportation risk for ESS DC block? Arthur, Lutz?
Yeah, I can start, and maybe Lutz can continue. So your BSS manufacturer, or they should have kind of pre-shipment preparation procedures that we will, as part of the FAT, that we will overview with them, making sure that it's done correctly. So, for example, you need to have your battery racks correctly attached so that the battery packs, of course, won't move during the transportation. But after, to make sure that no risk happens, that's also why that no issues happen as part of the transportation. That's also why you need to perform a full site commissioning, so that you can actually compare the data from the FAT and the data from the ACAT. And I would say that's why it's super important to have comprehensive data from the FAT, so that when you receive the BESS on site, if you find issues, it will fasten your claims either with the transport company or with your BESS integrator. Lutz, I don't know if you want to add anything about this.
Nothing to add.
Okay, thank you, Arthur, for answering that question. We still have some questions, but I'm just mindful of time. So all the questions that we were not able to answer during the Q&A session, we will follow up with them in writing. And to conclude this webinar, I think one thing is certain, that traditional testing approaches are leaving critical blind spots, ones that actually can derail projects, drain budgets, and undermine confidence. So let's agree that by uncovering issues early, before they become costly failures, as Arthur presented, this new BESSential approach ensures smoother commissioning, fewer disputes, and a stronger return on every project. So thank you again for joining us today and for being part of this important conversation. I thank you, Lutz, for your interesting insights on how volytica diagnostics tool work, and also you, Arthur. If you need advice or consulting on PV and BESS quality assurance or ESG and traceability matters, feel free to reach out to Arthur. And if you need your batteries to be tested at 100%, then reach out to Lutz. Thank you, and see you in the future webinars.
Thank you.
Thanks a lot.
Visit Sinovoltaics.com to learn more.